Hey there, Python enthusiasts! Welcome back to day 69 of our 100 Days of Python series. Today, we're taking reinforcement learning to the next level. If you're ready to dive into deep Q networks, policy gradients, and actor-critic methods, then you're in the right place. Let's jump right in. So, what's the next step after learning Q-learning? Enter deep Q networks, or DQNs. DQNs combine the power of deep learning with reinforcement learning, allowing us to solve more complex problems, like playing video games. The idea behind DQNs is to approximate the Q-value function using a neural network. This allows the agent to handle large, complex state spaces, like those found in video games. This code sets up a basic DQN to play the cart pole game. The neural network learns to predict the Q values for different actions, allowing the agent to balance the pole effectively over time. After training, you can save the model and use it to evaluate the agent's performance. While DQNs are powerful, they're not the only game in town. Policy gradients offer an alternative by directly optimizing the policy, basically, the agent strategy, without needing to estimate Q values. Policy gradient methods work by tweaking the policy in the direction that increases the expected reward. These methods are particularly useful in environments with continuous action spaces. This code demonstrates how to train an actor network using policy gradients. The actor directly learns the optimal policy by maximizing the expected reward for each episode. Reinforcement learning isn't just for games, it's revolutionizing many industries. From self-driving cars to financial trading algorithms, reinforcement learning is being used to solve complex real-world problems. Imagine training an autonomous drone to navigate through a forest, or developing a trading bot that learns to maximize returns in a volatile market. The possibilities are endless. That's all for day 69. Today, we explored advanced reinforcement learning techniques, including deep Q networks, policy gradients, and actor-critic methods. If you found this video insightful, make sure to like, subscribe, and hit the notification bell. Join me tomorrow for day 70, where we'll continue our Python journey. Keep coding, and I'll see you next time.